Alright, so continuing on from the last video, I found that -3 is one of my roots, which means that x plus 3 is one of my factors. And I also found that I have the polynomial x cubed plus 3x squared plus x plus 3 left when I divide by this x plus 3. So these two factors being multiplied together should give me my original polynomial, and it will. Okay, so from here, now I'm going to clean this up a little bit, get rid of all this stuff. From here, what do? I have this polynomial, x cubed plus 3x squared plus x plus 3 times my x plus 3 that I divided out before. Now, I have a couple of options. I can take this polynomial and test my remaining roots, or my remaining possible roots, by testing these the 3, the 9, the -9, or I could also test the -3 again. So don't forget, I could have a multiplicity greater than 1 of any of these factors. So I could use -3 again. I haven't necessarily eliminated it because it is one of my roots. So back to this. I could test the remaining possible roots, or I can try to factor what's left. So let's take a look at this polynomial, x cubed plus 3x squared plus x plus 3. Well, if you notice that I can use grouping, good for you, because I can. We can't forget about this tool belt. We learned the tool belt so that we can refer to it whenever we need it, and we're going to need it for the rest of this chapter. So let's use it. So okay, back to grouping. I can pull out an x squared from this first group, and I have left an x plus 3, and I can factor out a 1, we'll call it, from that second group and have x plus 3. So now I can pull out a GCF of x plus 3 in both of these groups, and I get back x squared plus 1 times x plus 3. So that's when I broke down just this polynomial here. So my final answer, I need to remember the original x plus 3, this one over here, that I factored out before. So my final answer, my final answer in factored form is going to be these three factors. That's the product of f excuse me. Each one of these are a factor of f of x, so the product of these three factors will give me f of x. So, if I want to find my zeros now to finish the problem, another way of writing this, actually, let me do that first, would be x squared plus 1 times x plus 3 squared. So now if I want to find my zeros, I drop a t, as I like to say. I'm going to get x squared equals -1, or x equals plus or minus I. And I'm going to get x equals -3. So all of my roots for this polynomial are plus or minus I and it's not a 3, and -3. Now if I were asked to find only the real roots, I wouldn't worry about my I, and my final answer would be x equals -3. And that's it. So don't forget, whenever you use synthetic division up here and you found one of your roots, you might be able to just factor what's left. There you go.